Assalamu alaikum everyone, and today we are going to be talking about verifying trigonometric function. Now, in our series of trigonometry, we're going to be facing a bit of problems identifying the trigonometric identities and verifying them, which is an entire nightmare. Even when I heard it and when I learned it, it was a nightmare for me. But after a while you get used to it and get better. Just like I say a few videos ago, that to always practice, well, this shows it. Whenever there's an identity, they'll always have one side and the other side, and we need to simplify both sides strategically to prove that these are equal. If they're not equal, the trigonometric function, the trigonometric identity would not be verified, therefore not be an identity. Whereas if they are equal, then it will be verified as a trigonometric identity. Now, since this is so tough, we're going to start with an easy example. Well, as easy we can get. This is one of the more simpler examples. So basically we turn them in a different form. That is strategy 1. Using them as a different form to verify this as a trigonometric function. Now, since it is the reciprocal of sine x, we're going to use that. And since tangent x is basically sine x over cosine x, we're going to put that. And this is basically no change at all. So we can keep the other side as it is. But we don't need to change it at the moment. So we can cancel the signs, giving 1 over cosine of x. Now the other side, if the cosecant was the reciprocal of sine and the cotangent was the reciprocal of tangent, then the secant would be the reciprocal of cosine, which means 1 over cosine of x. That means both sides are in fact equal. So this trigonometric identity has been verified. That means this is a trigonometric identity. Now let's try with the harder example. Sine x times tangent x plus the cosine of x will be equal to the secant of x. We're still going to use the same strategy, and so we're going to use sine of x times sine x over cosine x. Then we have the plus cosine x. Then there is the secant of x. Now here is the clever part. If we add these up, now here's the clever part. We can multiply this by cosine of x over cosine of x. Why do I keep calling cosecant instead of cosine? I think it's because they sound similar. And since we're multiplying by 1, it'll basically be nothing. Nothing has changed. Let's keep the 1 over cosine of x on the other side. And here we can get rid of this cosine. So there will be cosine squared of x over cosine of x. Here would be instead of the cosine, there would be the sine of x over the cosine of x. Here, this might seem arbitrary to multiply all these stuff, but we need them so that we can combine this fraction, which we can because we have the same denominators. So sine of x plus cosine squared of x all over cosine of x should be equal to 1 over cosine of x according to this identity. Now here's the tricky bit. We can use a Pythagorean identity to verify that this is a trigonometric identity. So what we can do is that we know sine square of x plus cosine square of x is equal to 1. So we can cut all this large thing up and just give 1. And well, now we have a very easy expression for this. So this is a verified trigonometric identity. I don't know why. We learned strategy 1. That is to express functions in a different form, like the fraction form. Second is to use the Pythagorean identities, such as 1 minus sine squared of x equals to cosine square of x, and 1 minus cosine square of x equals to sine square of x. These are the two expressions that can come in handy whenever we're verifying a trigonometric identity. The third, and in my opinion, the simplest one, is to use the fractions. Now the overall strategy is to start doing things that are algebraically. Now the overall strategy is to start doing things that are algebraically valid, even though you don't know why you're doing them. You just have to do something that is 1, algebraically valid, 2, can be helpful. You don't just go whole in your entire life just multiplying it by 1. We need something useful. Now let's see an example. 1 plus tangent square of x equals to secant square of x. Now here there are 2 terms on one side and 1 term on the other. And sometimes combining terms is a good idea. But first we need to make the denominators equal to combine these terms. Now that part can be easy with the following fractions. First, the tangent square would be just a piece of cake. Sine square of x over cosine square of x. Now we focus on the denominator here. Since it is the cosine square of x, we know that anything divided by itself is equal to 1, and fractions are the same thing as division. So we can basically turn this into a fraction, then use cosine square of x plus sine square of x. Oh, and we keep this. So basically this will be equal to 1, and then as you can see, that very hard term turns out to be a very equal simple and very easy and is a verified trigonometric identity. Now let's go for the hardest example in our video, and because why not? It's getting fun more and more we get through it, because more and more we're learning that these hard terms, these are the things that look like hard terms, but with easy things like fractions, we can easily derive them. So let's go with a harder example, since it's just so fun. Okay, if I just told you what this is, it would take around half a minute. Right, so there are many ways we can, verify this if it is equal to 2 secant squared of x or not. 2 cotangent squared of x. Now the easiest way is to use 3 of the identities that I have in this notebook, which I'm bringing into the camera to, show you what these are. I'm doing this rather than the board because it's a bit easier. So these identities will be what we're going to be using. Seeing as sine squared of x plus cosine squared of x is equal to 1, the thing that we have been writing since half the video is still here. So that's the first identity we used, and is probably the most used identity of this video. Then 1 plus cotangent squared of x is equal to cosecant squared of x. So we can basically just give this, and 1 plus tangent will give secant squared of x, the one we just saw earlier, and now we're going to break these apart into 2, yes, not 1 but 2 examples. So basically we're going to have the reciprocal, since it's basically multiplying it by the reciprocal. Dividing a fraction is, we're just going to write cosine on the top and 1 on the bottom. Now what this does, now we can just not write the 1, but what this does is cancel out the 1's, giving cosine squared of x over sine squared of x. Remember tangent squared of x being equal to sine squared of x plus cosine squared of x. Since this is flipped and this is the reciprocal, and cotangent is the reciprocal of tangent, this is therefore verified. And by all these getting to the harder level, the more examples we go, I think we have a very solid understanding on what the verifying trigonometric functions are. Now remember that just watching this video won't help you. Perhaps it wouldn't even help you halfway through your test, because I doubt that it's 90% certain that this problem would not come in your test. So you have to take the concept of this video and to practice the functions and everything, and the identities, how to simplify them and everything, so that you can find harder and harder problems and probably master this verifying trigonometric identities, which at first was a nightmare to me. After I practiced, well, I got through harder solutions. Anyway, so that's all there is to it. If you want more math and science videos like this, remember to subscribe. There's the little red button down below. There, you just click it if it's red. Then you can like the video and you can share it to other people who have difficulties with similar stuff like verifying trigonometric identities, which I presume if your friends might have a bit of a problem in, because it was a nightmare to me when I first did it. So you can share this video, and thank you for watching, and I will see you next time. Bye.